Section 8.3 takes us through the exact same concepts as Section 8.2, but this time we're going to be talking about a geometric sequence in series. A geometric sequence in series is where you've got a common ratio instead of a common difference. And to sum it up in one word, or in a group of words, we are going to be talking about multiplication instead of addition. So when we are looking at each term in a series or a sequence, we're looking at being multiplied by a constant as opposed to being added by a constant. So when you hear common ratio, you're thinking of multiplication of a sequence. So finding the common ratio in the following geometric sequence, 3, 6, 12, 24, you can see this is being multiplied by 2. 1, 1/2, 1/4, 1/8, that's being multiplied by 1/2. So you might want to say divided by 2, and that's okay, but realistically, common ratio is being multiplied. So we want to think about this in terms of multiplication. So now we want to come up with the general term for the arithmetic sequence, or excuse me, for the geometric sequence. And the general term follows the format a sub n is equal to a sub 1 r raised to the n minus 1. Now, let me explain what this formula is saying. I'm going to do it on a separate sheet of paper here. So we've got the formula a sub n is equal to a sub 1 times r raised to the n minus 1. So a sub n is my ending term. A sub 1 is my starting term. So this right here is ending term. A sub 1 is starting term. R is going to be the common ratio, and then n is going to be number of terms. So let's look at this. Let's say hypothetical situation, I give you that a sub 1 is equal to 36, and the ratio is going to be 1/2. That means for every single term of the sequence, a sub 1 is going to be 36. A sub 2 would then be 18, because I multiply by 1/2. A sub 3 is 9, which is multiplied by 1/2. A sub 4 would then be 9/2, once again being multiplied by 1/2. A sub 5, 9/4, once again being multiplied by 1/2. A sub 6, 9/8, 1/2. A sub 7, 9/16, being multiplied by 1/2 again. And then a sub 8 would be 9/32, multiplied by 1/2. That n indicates the number of terms in my formula over here. Now, why does the n minus 1 come up? Well, the n minus 1 comes up because every time I look at the number of terms I've got, the number of times I multiply is going to be 1 less. So look at, if I go to, just ignore this all over here. If I go to 2 terms, a sub 2, I only multiply by 1/2 once. If I go to 3 terms, to a3, I multiply by 1/2 twice. If I go to a4, I multiply by 1/2 3 times. So that's why we've got the n minus 1 up there. It's the number of terms we're dealing with minus 1, which tells us how many times we've got to multiply the ratio by. Now, the piece that I want to show you is that this might not always have to be a sub 1. Let's give the hypothetical situation that I want you to find a sub 10. And let's say that I start by giving you a sub 4, which is 9/2, a sub 5, 9/4, a sub 6, 9/8. So let's just say I give you those. Or to even make it a little more challenging, let's say I give you, let's keep it like this. A sub 7 is 9/16. And I want to find a sub 10. Well, I know if I were to follow this pattern out, 1, 2, 3, a sub 8, a sub 9, a sub 10, And I know that every single one of these are being multiplied by 1/2. So I'll get some value in a sub 8, some value in a sub 9, and then some value in a sub 10. I could apply my formula, which a sub n is equal to a sub 1 times r to the n minus 1. I don't necessarily have to say a sub 1 in this equation. A sub 1 just indicates my starting term, and then this n minus 1, that's the n is the number of terms to get to the ending term. So a hypothetical situation, if I wanted to find a sub 10 here, I want my ending value to be a sub 10. I know a sub 1 is going to be 4, and then I could use the exact same approach, where I take the number of terms that I've got up to a sub 10. So don't feel like this has to be a sub 1 every single time. So if I were to solve this one out, a sub 10 is equal to a sub 4, which is 9/2. My common ratio is 1/2. And then the number of terms to get from 4 to 10, 1, 2, 3, 4, 5, 6, 7, is 7 terms. So 7 minus 1 would be 6. So realize that you do not always have to have a sub 1 here. It could be a sub 4, it could be a sub 8. It's whatever my starting value is. And then this n value is the number of terms from whatever my starting value is to whatever my ending value is. That concept's going to help us in a little while as we get down to solving some of our sequences. So example number 2, we want to answer the following questions about the geometric sequence. First, we want to find the nth term of a geometric sequence with a common ratio of 2 and a sub 1 is equal to 5. So this one, I just want to know what that general formula is, because I see the nth term. We've called that the explicit formula or just the general term formula. So a sub n is equal to a sub 1 times r to the n minus 1. I give you a sub 1, I give you the common ratio. So a sub n is equal to 5 times 2 raised to the n minus 1. And we've got to stop at that point. I've seen some students make the mistake saying 5 times 2 is 10. But remember, with your order of operations, you've got to first solve exponents before you do multiplication. Since my unknown is in my exponent, I can't do the multiplication piece there to simplify. Second part here, finding the 12th term of the geometric sequence, 1, 3, 9, 27. We want to find the 12th term. And once again, I can list out the first 12 terms, but we want to find this using our formula. We know the formula, a sub n is equal to a sub 1 r raised to the n minus 1. So in order to solve this, I need the common ratio and I need my starting term. I can see here my common ratio is being multiplied by 3 every single time. That's times 3. So r is equal to 3, and I know a sub 1 is going to be 1. So here, a sub 12 is going to be 1 times my common ratio of 3 raised to the 12 minus 1. Since we're looking for the 12th term, we plug in n equaling 12, which simplifies to a sub n is equaling 1 times 3 to the 11th. Actually, it's a sub 12 is equal to 1 times 3 to the 11th. So then, a sub 12 is equal to 177,147. The last example here is where we're going to use that second idea of the geometric series formula, where we're going to say a sub 1 is not necessarily our starting value. So here, let's find the 8th term of the geometric sequence with a 3rd term of 5/4 and a 6th term of 5/32. So since I'm low on space right here, I'm going to put this on a separate sheet of paper. I know a sub 3 is going to be 5/4. I know a sub 6 is going to be 5/32. I want to know what is a sub 8. So just as we did last time, with our arithmetic sequence, we first want to figure out how does each term change. So for this one, we want to start by finding out the common ratio. And with this, we know A3 to A6 is going from 5/4 to 5/32. So I know A sub n is A sub 1 r n minus 1. And if I were to look at A3, A4, A5, A6 as the blanks in my series, going from 5/4 to 5/32, there's 4 terms there that I'm dealing with. So I've got to deal with 4 separate terms. So here I'm going to say A sub 6 is equal to A sub 3. This is going to be my starting value, my ending value, and then r raised to the 4 minus 1, because I see that there are 4 terms right there. So really, this is A sub 6 is equal to A sub 3 times r cubed. Now we know that A sub 6 is equal to 5/32. We know A sub 3 is 5/4. So we can solve this out. Multiply both sides by 4/5. So 4/5 times 5/32 is equal to r cubed. 5's cancel out. 4 and 32 reduce to 1 and 8. So 1/8 is equal to r cubed. Take the cubed root to both sides. So then r is going to be 1/2. Now that I know that r is 1/2, I can come back to my original formula. A sub n is equal to A sub 1 r raised to the n minus 1. And I don't care if I use A3 or A6 as my starting value, but A sub 8, I'm just going to use A sub 6 here because it's closer. A sub 8 is equal to A sub 6 r, and then how many terms do I have to go from A6 to A8? Well, it's A6, A7, A8. There's 3 terms there, so it's 3 minus 1. So what I'm dealing with is A sub 8 is equal to A sub 6 r squared. We know A sub 6 is 5/32. We know r is 1/2, and we'll square that. So A sub 8 is equal to 5/32 times 1/4. So A sub 8 is equal to 5/128.